projectile can have the same range r for two angles of projection. If t1 and t2 be the times of flight in the two cases, then what is the product of the two times of flight? So if this is a ground and this is a trajectory of the projectile, this would be the initial velocity of the projectile that makes an angle theta with the horizontal, and it has a magnitude of v. So this velocity has some vertical and some horizontal component. The horizontal component is v cos theta, while the vertical component is v sin theta. We have the equation displacement is equal to initial velocity into time plus half of acceleration into the square of time. Applying this in the vertical direction, we can calculate time of flight. Total vertical displacement is 0, initial velocity is v sin theta, and the acceleration is minus g. So time of flight would be equal to either 0 or 2v sin theta divided by g. Of course, time of flight cannot be 0 because that only refers to the instant of projection or instant of launch of the projectile. Hence we have time of flight is equal to 2v sin theta divided by g. Now range of the projectile would be given by time of flight into the horizontal component of velocity. So this is equal to 2v square sin theta cos theta divided by g. Now if we assume that for two values of theta which are phi and pi by 2 minus phi, the range would remain the same because sin phi cos phi is the same as sin pi by 2 minus phi into cos pi by 2 minus phi. So we can say here that r1 is equal to r2. And let's call it r. This r would be proportional to sin phi cos phi. For the time of flight, t1 would be proportional to sin phi and t2 is proportional to cos phi. Therefore, we have t1, t2 to be proportional to r, and hence option A is the answer.